Okay, when solving trig equations, we're going to be using inverse trig functions to be able to solve trig equations. We'll be using inverse sine, inverse cosine. We're dealing with inverse sine, inverse cosine. This will undo our trig functions of sine, cosine, tangent. It allows us to solve for an angle whose sine, cosine, and tangent are a specific value. In mathematics, and once again, this is somewhat the reason why people like mathematics, there are rules of doing things. There are rules to follow to do things mathematically. If there are rules to follow to do things, there are also rules to follow to undo those exact same things. If I had an equation that x plus 7 is equal to 13, we can eliminate that plus 7 by subtracting 7. It undoes the process of addition by 7. If I have 5 times x is equal to 37, I want to get rid of the multiplication by 5. I can divide by 5. It undoes the multiplication by 5. If I have x squared is equal to a value, I can undo that x squared by taking the square root of both sides. If I have a logarithm, I could take 10 to that logarithm to undo that process. So all the processes that we do mathematically also have undoable processes. Well, that's the exact same thing with trig functions. If I have the sine of an angle, to get rid of the sine, I can take the inverse sine. Or tangent, inverse tangent. They're undoable processes. It allows us to solve for angles. We've talked about this already. Principal values are calculator values. Okay, your calculator is set up for your principal values, so it's automatically set. You don't have to sit there and overthink this process because the calculator will already give you the principal values. Inverse sine, inverse tangent are between negative 90 and 90. Inverse cosine is between 0 and 180 degrees. When we take the inverse sine and inverse cosine, we get two values. Just like if I ask you to solve this equation, x plus 3 quantity squared is equal to 25. Yes, if I wanted to, I could FOIL out x plus 3, get into a quadratic equation, and solve for two solutions. But we've advanced our thinking and learned how to solve this in a different way. I got x plus 3 quantity squared. But what would we have to do to both sides to get rid of the square? Square root. So we could square root here, we could square root here. So we have x plus 3 can equal a value of 5, or it can equal a value. Right? Equal 5, but also what? X plus 3 could equal 5, or x plus 3 could equal what? Yeah. But I physically had to do the process to be able to solve this equation. Negative 5. We get two solutions. So we have x plus 3 could equal 5, or x plus 3 could equal negative 5. So now it's a process of subtracting 3 throughout. So we have x is equal to 2, or x is equal to negative 8. When you physically have to write the square root to solve a problem, you get two solutions. Because if I would put 2 in there, I have 2 plus 3, which is 5. I square that, I get 25. But if I put the negative 8 in there, I have negative 8 plus 3, which is negative 5. If I square negative 5, I still get the value positive 25. So I get two solutions there. So when you do the square root, when you physically have the square root to solve a problem, and we've talked about this earlier in the year, you physically have the square root to solve the problem, you have to make sure you get plus or minus in there. Well, when taking inverse sine, inverse cosine, you get the exact same thing. When you take the inverse sine of an angle, of a value or inverse cosine of a value, you get two solutions. You get one, which is your principal value, but the second one is its supplement. The principal value and its supplement. And when you take the inverse cosine, you get the principal value and its opposite. You get two solutions. Inverse sine to get the principal value and its supplement. S goes with S. We take the inverse cosine, you get the principal value and its opposite. Now when dealing with a supplement, when you deal with supplement, and this is review from back in trig class, and you're in theta, when we're in theta, we get 180 minus our principal value, whatever that principal value is. If I have a degree of 20 degrees, my principal value is 20 degrees. My supplement to that is 180 minus 20, or 160 degrees. If my principal value comes down to 150 degrees, my supplement is 180 minus 150, which is a value of 30 degrees. But when dealing with degrees, when dealing with radians in x, when you're in the x variable, you're in radians. So what we have to do is we have to convert this to pi minus our principal value. Which is 3.14 minus our principal value. I'm sorry, I jumped ahead. So we have some equations here we're going to solve. Solve the equation, general solutions, and leave the solutions in terms of pi. Now, when it states to leave things in terms of pi, when it states to leave things in terms of pi, that is sort of an indicator that your solutions are going to be a multiple of 30, multiple of 45, or multiple of 90. Which are easier to convert into terms of pi. Pi over 3 is 60 degrees. Pi over 6 is 30 degrees. So, what I suggest that you may want to do with this is, even though we have an x variable there, leave it in a degree form to see what you come up with first off. I have the sine of x plus 3, or x plus pi over 3 is equal to 1/2. We have the value of the sine there, and we want to get rid of the value of sine, or the operation of sine. So to get rid of sine, Cole, what are we going to do to both sides? Subtract. To get rid of sine, we're going to subtract. What are we going to subtract?
Do the inverse.
Do the inverse?
Yeah.
You sure?
Yeah.
Which one?
The inverse.
All right, there we go. I will tell you this right now. I've been teaching for a long time, a very long time. I got my walker out. We've gone through trig functions here. That was the first time anybody ever said to subtract it all. I usually get the division in there. First time. There you go. So we take the inverse sine of 1 tooth. So we take the inverse sine of 1 tooth. Okay? In a degree form, what do you come up with, Sarah? 30 degrees. So we get the value of 30 degrees. Okay, so we have x plus pi over 3 is equal to 30 degrees. But I need to keep this into a degree form or a radian form in terms of pi. So I can convert my degree measure into pi over 6. No, Mr. Black, how are we doing today? You joining my class? You would. We got a seat right beside our Mr. Wenger back there. You can sit there. You can sit there and you can merge your brain powers together.
That'd be awesome.
Yeah. You'd be able to do a Vulcan mind meld. How would that would be awesome. The Vulcan mind meld.
I don't know what that is.
You don't know what that is. He's not living. You just walk right through my class. When you walk through my class, you open yourself up to that. But since we took the inverse sine, we also have to worry about a second value. If I take the inverse sine, we have also the supplement. Which would be what, Amber? What's the supplement to 30 degrees? Supplement? $150. So we have x plus the pi over 3 is equal to 150, but we have to convert that into terms of pi. Which is what, Courtney?
5 pi over 6.
So we have pi over 6 and 5 pi over 6. Once again, how I go, this is my mental process. See how that works? Mr. Black started making a couple of steps this direction. He was going to start walking through again. Turn around. We'll see Mr. Black walking down the hallway here. Oh, right. Come on, Mr. Black. Don't disappoint me. Come on, Mr. Black. He disappointed me. All right, so what we have to do is, and once again, what I take a look at here, my 30, 60, and 45, what do I have to do to one of those values to get to 150? Well, I have to multiply 130 times 5 to give me 150. So that pi over 6, I can multiply by 5. So I get 5 pi over 6. And that's how I can do some mental math with it. In any case, to solve, we have to subtract our pi over 3 from both sides. I usually write that with a little bit of spacing in there. This will allow me to get my common denominator. I need to get 6 as my denominator. I got a 3 right now. So what do we need to multiply top and bottom by here? Justin? 2. So we have negative 2 pi over 6. So I have pi over 6 minus negative 2, or minus 2 pi over 6. So we have a negative pi over 6. And my negative 2 pi over 6 will come over here also. So I have 5 pi over 6 minus 2 pi over 6 will give us 3 pi over 6. Which is pi over 2. Okay, we want to get general solutions. Okay, if you remember back to trig class, we have our general solutions. And get those general solutions, we add or subtract our period n. Well, our b value here, if we go back to dealing with our graphs, our b value is a value 1. So the period here is 360, or 2 pi divided by 1. So we have plus or minus 2 pi. Would be our two general solutions. So we take a look at the second one. Have cosine pi over 4 plus x plus pi over 4 equals square root of 2 over 2. If I can get rid of the cosine, what do we have to do? Inverse cosine, inverse cosine. So once again, I would start out in the degree mode. Take my inverse cosine as square root of 2 over 2. And then convert that into a radian form in terms of pi. Make sure you close your parentheses out and watch your parentheses here. Or make sure you pull out of the radical. Once again, that's one of my banes. I never pull out a radical when I have the newer calculator. So everything ends up being underneath the radical. Inverse cosine square root of 2 over 2. Lexi, what do you come up with? 45 degrees. We have 45 degrees, which is our pi over 4. Okay, see inverse cosine. Take the inverse cosine, we get our second value. Inverse cosine is the principal value and its opposite. So we have 45 and negative 45, so we have pi over 4. Negative pi over 4. Solve this, we have to subtract our pi over 4s. Over here, we cancel out to 0. Plus or minus the period n. And then we have negative 2 pi over 4. which is negative pi over 2, plus or minus the period n. Our b value here is a value of 1. So the period is 2 pi divided by 1, which is 2 pi. So here would be our two general solutions. Sine of x cosine pi over 4 cosine x sine of pi over 4 is equal to 1, 2. Now we have to think back. We need to shrink this out into something that we can work with. If I have sine of something, cosine of a second, plus the sine of that, cosine of the first times the sine of the second, which one of our angle addition formulas do we have? Or subtractions? We got sine A cosine B plus cosine A sine B. Which one do we have? Kylie? We have an A, we have a B, we have an A, we have a B. Sine A plus B. So we take this back into sine of x over 4. Oopsie. Try it again. The sine of x plus pi over 4 is equal to 1, 2. Take your inverse sine of both sides. Get your two values. Again, subtract your pi over 4 from both sides. Once again, I usually leave some space out here, so it allows me to get my common denominator and redo my fractions. Common denominator of 12. So we have 2 pi over 12. and minus 3 pi over 12. And once again, my common denominator is going to be the same over here. So we have 10 pi over 12 and minus 3 pi over 12. So it gives you some room to work on to the right-hand side. So we have negative pi over 12 plus or minus over 2 pi n and 7 pi over 12 plus or minus 2 pi n. Cosine squared minus sine squared. What was cosine squared minus sine squared? Cosine squared minus sine squared. What was it? You remember? Sorry, what? Cosine 2x? Gives us cosine 2x. So once again, going through the exact same process now. Take our inverse cosine of both sides. Inverse cosine, negative square root of 3 over 2 is what, Brianna? Negative 30 degree. Inverse cosine, negative square root of 3 over 2. 150. We have 150, and then we have its opposite, which is negative 150. So 150, once again, is 5 pi over 6. And negative 5 pi over 6. Now we can think of this as dividing by 2, or we can multiply both sides by what? Dividing by 2, multiply by a half. And that might be easier to work with here. So we can multiply both sides by a half. That will give us 5 pi over 12. Plus or minus. Or negative 5 pi over 12 plus or minus. Now our b value has turned to 2. So the period is 2 pi divided by our b value, which is 2. So the period would just be the value of pi. So we have plus or minus pi n. I know it's easier working in degrees and working all these problems in degrees, but you also have to start advancing yourself in the mathematical world and handling the idea of radians and the values of pi. It's okay to sit there and do your inverse root functions in degree mode and then change them to terms of pi. That is fine. But you need to be able to once again start working yourself through the idea of solving equations in the radian forms in terms of pi. Again, as I said, it's big boy, big girl mathematics. Solutions have been posted for you. Last 10 minutes is yours. This is the last of our information in this chapter. So we'll start into a review mode.